The topic of this video is on Cpctc, this right here. And essentially that just means that corresponding parts of congruent triangles are congruent. So this is just an add-on to the end of a proof, okay? So let's say you've done the work. You in your 2-column proof, you have said something about a side, you've said something about an angle, and then you've said something about a side. And then let's say you've said triangle ABC is congruent to triangle XYZ, right? By side, angle, side, let's say, right? What you've done is right here, you've proved triangles congruent. And now that you've proven that they're congruent, anything that corresponds, any sides or angles that we didn't know, we now know that they're also congruent. So then you might be able to say, well, angle B is congruent to angle Y, and that's not a thing that we knew originally, nor could we prove it. But now that I know that they're congruent, I now know that they are, because they correspond, right? They're in the same place in the triangle congruency statement. So how we're able to say that is once you've done all of the congruency work that we've been working on this standard, once you finish that and you say they're congruent, you can list any other part of this triangle that is congruent and say Cpctc. The corresponding part of this congruent triangle is also congruent. That's what that means. So these are pretty basic proofs here, but this is essentially what it'll look like, right? So given this, this, and this, prove that M is congruent to P. Well, I'm going to use the 3 givens to prove the triangle is congruent, and now I can say that that extra part is congruent by Cpctc. All right, same thing here. If I were told that this angle here is congruent to this angle here, and that this side is congruent to this side, I need to prove that MP, this side right here, is congruent to NO. Well, there's nothing that I can say about that right now. I can only list, I can only kind of do my congruency, my triangles first, right? So I could say triangle MNP is congruent to triangle OPN, and that was given. I can say that MN is congruent to OP because that was given. And then I can also say NP is congruent to NP, and that's because of the reflexive property. And now I can say, well, these 2 triangles, MNP is congruent to triangle OPN by side, angle, side. And now, because I know that this triangle here is congruent to this triangle here, I can say MP is congruent to NO by Cpctc. So how do you know when to use Cpctc and when not to? The biggest thing is in your proof statement. So if you have a proof statement and it says triangle ABC is congruent to triangle XYZ, you know you're going to end in side, angle, side, 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 angle, angle, side, HL, and angle, side, angle. You'll end that way if it gives you a triangle statement. If it ends with prove AB is congruent to XY, or angle B is congruent to angle Y, something like that, where it's a side or an angle, you know you will end in Cpctc. That's kind of your landmark. Your landmark is your proof statement, okay? If you have any questions, always ask.